Let's get right into it. Welcome back to The Explainer. Today, we're diving into something truly groundbreaking in the AI space. We're looking at how a highly specialized dataset, developed under the Center for Tamil Natural Language Processing Research, or CTNL-PR for short, is literally rescuing a low-resource language in the modern AI era. It's a fascinating story about preserving deep cultural nuances through some seriously high-tech innovation. Now, to really grasp why this work is so absolutely crucial, we have to start with a massive foundational question. Why does global AI struggle so much with regional languages? Well, the reality is that those massive, state-of-the-art large language models we all know and love, they often fail completely when it comes to capturing critical local nuances. Sure, they might get the broad strokes of a major language, but when you throw in regional specificities, deep cultural context, and highly localized terminology, they just hit a brick wall. So here's our roadmap for unpacking exactly how researchers are tackling this. First up, we'll break down the challenge. Second, we'll look at the innovation itself. Third, we'll walk through the methodology. And finally, we'll explore the impact. All right, part one, the challenge, the linguistic AI gap. In the world of NLP, Sri Lankan Tamil is what we call a low-resource language. Basically, there's a severe scarcity of high-quality annotated text corpora explicitly built for it. And there's a massive disconnect happening right now. Most of the existing multilingual datasets for Tamil are heavily trained on Indian Tamil corpora. But here's the thing. Indian Tamil and Sri Lankan Tamil are not identical, not even close. So these broad global models completely miss the Sri Lankan Tamil context. They severely underrepresent regional linguistic variations, unique local place names, and very specific institutional and government terminology. So what exactly happens when we just ignore this gap? Well, things break down fast. Without that local context, downstream AI systems fail in some very specific, very frustrating ways. Everyday vocabulary gets completely misunderstood. Local organization names, missed entirely by the AI. Sri Lankan place names are either erroneously categorized or just straight up ignored. And vital government terminology gets lost in translation. This isn't just a minor glitch, it's a severe technological blind spot. I mean, you simply cannot build a functional document intelligence system or a reliable chatbot for Sri Lanka if the underlying AI has no idea how to recognize the names of its own towns, people, and institutions. Moving on to part two, the innovation, a regional AI solution. Enter the absolute hero of this explainer, the Sri Lankan Tamil NER datasets. This is a bespoke named entity recognition, or NR corpus, and it is designed entirely and precisely for Sri Lankan Tamil linguistic usage. NR, as you probably know, is a foundational NLP task. It's the core engine that identifies and classifies entities in text. You know, things like people, locations, and organizations. By creating a dataset built exclusively for Sri Lankan Tamil, the researchers under CNTL-PR haven't just compiled data. They've built a highly intentional, high-quality bridge designed to perfectly handle these regional variations. And the sheer scale and quality of this innovation really hit home when you consider the raw numbers. We're talking exactly 16,012 manually curated entities. Think about that for a second. This isn't just a bunch of messy data automatically scraped from the web. These are over 16,000 highly accurate, human-verified data points meticulously structured to train the next generation of AI. That is a massive undertaking. And the distribution of those 16,000 entities is incredibly deliberate. There's a huge emphasis placed on capturing locations and personal names. We've got over 8,100 location entities, tagged as BLOC, and over 4,500 person entities, tagged as BPER. That's rounded out by roughly 3,300 organizational entities. This specific breakdown isn't random. It directly targets the exact blind spots we were just talking about. It guarantees that the AI learns precisely how to recognize Sri Lankan geography and its people. The true beauty of having such a pristine, well-structured corpus is that it acts almost like a high-powered plugin. It's built to support and upgrade massive transformer-based architectures that are already out there. Heavyweight models like IndicBERT, mBERT, XLM Roberta, Merrill, and IndicBERT, they can all be fine-tuned using this exact dataset. We don't need to go and build a brand new foundational AI from scratch. We just use this highly refined data set to teach the world's most powerful language models a brand new, highly specific regional dialect. It's brilliant. All right, part 3, the methodology, the preparation pipeline. Now, actually creating a machine learning-ready dataset of this caliber, it is incredibly rigorous. The researchers mapped out an elegant three-stage pipeline to transform completely noisy, raw text into clean, abstract, machine-readable structures. It's a straight flow, starting with data collection, moving right into OCR and text normalization, and finally ending up with strict BIO tagging. For step 1, data collection, the team drew heavily from the Nullaham corpus, along with other relevant publicly available local sources. And their explicit goal here was absolutely crucial: capture authentic, realistic Sri Lankan Tamil usage patterns. They entirely avoided synthetic or machine-translated text because, honestly, relying on artificial translations would completely defeat the purpose of capturing genuine cultural and linguistic nuance. Then we hit step 2, which is arguably where the heaviest technical lifting actually happens. You see, Tamil NLP pipelines often have to start with scanned or image-based documents. In optical character recognition, or OCR, it is notoriously messy. The researchers had to aggressively normalize Unicode, clean up wild punctuation, normalize white space, filter out invalid characters, and basically perform severe OCR noise reduction. This step is absolutely vital. If you leave even a little bit of Tamil script error from a noisy scan in your text, those errors propagate exponentially into your token classification systems, completely ruining the AI's learning process. Once that text was finally pristine, they moved on to step 3, manual annotation, using the BIO tagging format. For those deep in the weeds of NLP, here is exactly how this mechanism works under the hood. The B stands for at the beginning of an entity. The I means the token is inside an entity. And the O is simply a non-entity token, just your regular everyday text. This is the standardized, abstract mathematical structure that our language models actually read and learn from. To really visualize this, think about how specific Tamil tokens map directly over to these abstract categories. A specific personal name gets assigned a B-per tag, mapping it directly to the entity type person. A specific local city or region gets tagged B-loc for location, and a university or institution becomes B-org for organization. It is strictly through this incredibly tedious, token-by-token manual labeling process that raw human culture is literally translated into digital intelligence. And we really need to take a second to acknowledge the sheer difficulty of this feat. I mean, building this was no walk in the park. The CTN-LPR team had to overcome some incredibly tough, language-specific hurdles. Tamil has intense morphological complexity, meaning words are constantly changing shape based on their grammatical role. Combine that with severe OCR noise, the headache of detecting where one token ends and another begins, and aligning subwords, it becomes pretty clear that this dataset isn't just a collection of words, it's a genuine technological triumph for low-resource NLP. And finally, part 4, the impact. Real-world AI future. So why is this pristine, hard-won dataset such an absolute game-changer for downstream AI applications? It's because NER acts as the foundational layer. By fine-tuning models with this specific dataset, developers can now build highly accurate RAG pipelines, retrieval-augmented generation. They can build brilliant semantic search systems and fully functional Tamil chatbots that actually understand local contexts. It empowers automated government document analysis, and it makes the generation of rich, culturally accurate knowledge graphs totally possible. Ultimately, it takes AI in Sri Lanka from being this broad, clunky tool to a razor-sharp, highly precise instrument. I want to highlight a direct quote from the researchers themselves. They state that this work is, quote, an important step towards strengthening the Sri Lankan Tamil NLP ecosystem through high-quality entity annotation. And that just brilliantly captures the essence of this whole project. It's not just about wrangling data on a server. It is a deeply mission-driven effort to lay down a vital foundation for preserving cultural heritage and ensuring genuine technological equity in our digital age. We've really seen today how meticulous methodology and a laser focus on local context can bridge massive technological gaps. So as we wrap up this explainer, I want to leave you with one final thought to chew on. As AI continues its rapid global expansion, how will preserving and integrating these regional languages shape the ultimate future of global AI? Are we heading toward a single, homogeneous global voice, or a rich tapestry of deeply understood local contexts? The incredible work done by CTN-LPR proves that with enough dedication, we can actually force technology to adapt to culture rather than the other way around. Thanks for joining me on this explainer, and keep asking the big questions.